Hello students and welcome back to For Knowledge. How are you doing? In this session, we are going to discuss about addition, multiplication and division of complex numbers. Okay. So first of all, what is a complex number? Suppose you have two real number A and B. These are two real numbers. Then if we express this number, you express a quantity using these two like A plus iota B. Okay, suppose this is as z equal to a plus iota b. This number where both the components are coming from real field and the second component, that is b, is associated with iota. This type of number we call them as complex numbers. Now what is iota? What is I? I is nothing but square root of minus 1. I is nothing but square root of minus 1. This term was first used by Euler. Okay, the great mathematician Euler, he first introduced the term I equal to root under minus 1. So, if we express a number z as a plus ib, this number is called a complex number, where a is called the real part of the complex number, or REZ, real part of the Z, and I, the term associated with iota or I, B. This part is called imaginary part or MZ. So if you have encountered such number where there is a real part and there is the imaginary part, how do you understand what is the imaginary part? The part that is associated with I. This type of representation, this is called a complex number. Okay, so now we are going to discuss about how to apply the algebraic operations on the complex numbers. Okay, I hope this is clear. Now addition. Addition is a binary operation. Okay, binary operation means where you need two operands to get operated. Okay, so first is addition. So for addition, we need at least two complex numbers z1. Suppose z1 is denoted by a1 plus ib1, where a1 and b1 are coming from real number. And suppose z2 is there, which is a2 plus I times b2, where a2 and b2 are also real numbers. Then how do we add them? How do we add them? z1 plus z2. This is nothing but a1 plus ib1 plus a2 plus ib2. How do we add them? Very simple. Just component wise add. That means add the real part with real part, a1 plus a2, plus I times add the imaginary part with imaginary part. That means these two will be added, a1 plus a2, and b1 and b2 will be added along with the iota. This is how we perform the complex number addition. Same for my subtraction also. If we change this plus by minus sign, then just here there will be a minus sign. So a1 minus a2, the real part will be subtracted, plus I times b1 minus b2. As simple as that. So addition and subtraction are nothing different, they are same. So basically, if you understand the addition part, subtraction is nothing but very easy. So let's take an example. Suppose z1 is 2 plus 5i and z2 is minus 3 plus 7i. How do we add them? z1 plus z2. How do we add them? That is 2 plus 5i plus minus 3 plus 7i. Just add component wise. That means 2 minus 3 plus I times 5 plus 7, which is nothing but minus 1 plus 12i. Simple. Take another one. z1 equal to 6i z2 equal to 7 minus 5i. Okay, we need to perform the subtraction. We need to perform z1 minus z2. So component wise addition, component wise subtraction. So basically here the real part is nothing. There is nothing in the real part. That means the real part is 0. That means the real part is 0. So 0 plus 6i minus 7 minus 5i. So component wise subtract 0 minus 7, that is minus 7, and plus I times 6 minus of minus 5. That means the answer will be minus 7 plus 11i. As simple as that. As simple as that. Minus 7 plus 11i. That is how we perform the addition and subtraction. Now there are two properties for addition. Number one is it is commutative. Matrix complex number addition is commutative. That means if you have two complex numbers z1 and z2, and if you perform z1 plus z2, or whether you perform z2 plus z1, you will get to the same result. You will get to the same result. This is the first property, property of commutativity. And the second property is property of associativity. That means if you have three complex numbers, that is z1 plus z2 plus z3, z1 plus z2 plus z3, you have three complex numbers. Whether you first add z1 plus z2 and then add z3 to the result, or whether you first add z2 and z3 and then add z1 to the result, you will get to the same result. Okay, so this is the property of commutativity and associativity. That's how we perform the matrix complex number addition, and these are the properties that complex number addition follows. I hope this is clear. Shall I erase this? Hope so. Now let's move on to complex number multiplication. Let's move on to complex number multiplication. This is a little bit tricky part. For that, we need to understand how I behaves, iota behaves. What is iota? Iota is root under minus 1. Fine. What will be the iota square? What will be the iota square? This is nothing but minus 1. The square of root under minus 1, that is nothing but minus 1. So you have to remember this result. Now, since this is a binary operation, complex number multiplication is a binary operation. Binary operation means you need at least two complex number to multiply. So let z1 is a1 plus I times b1 and z2 is a2 plus I times b2. We need to find what is the result of z1, z2. So z1, z2, a1 plus ib1, a2 plus ib2. Simple multiplication. First, do the simple multiplication. That means a1 into a2 plus a1 times ib2. That means I times a1 b2 plus I times b1 into a2 plus I square b1 b2. Very simple, right? Now, what is I square? What is the I square? I square is nothing but minus 1. This is becoming a real number. Okay. If I is present, that is the imaginary part. Okay. But if I square is present in some quantity in the complex number, that means I square is nothing but minus 1. So this entire quantity I square b1 b2 is nothing but minus b1 b2, because I square is minus 1. So this is converted into real part. So we have to associate this with the real quantity. That means we have to associate this part with A1, A2 where there is no iota. So A1, A2 minus 1, that means minus B1, B2 plus the iota terms, that means A1, B2 plus B1, B2. So this is where the complex number multiplication gets a little bit complicated, but if you go through the formula once again, then this becomes very easy. Nothing tough here. Okay. So this is nothing but A1, A2 minus B1, B2. This is the real part of the result plus I times A1, B2 plus B1, B2. Okay. So if this is clear, let's take an example. Suppose Z1 is 2 plus 3i and Z2 is 1 plus 5i. We need to find Z1, Z2. So Z1 is Z2 is nothing but 2 plus 3i into 1 plus 5i. Very simple. Just multiply accordingly. So 2 into 1, that is 2, plus 2 into 5i, that is 10i, plus 3i into 1, that is 3i, minus 15i square. Sorry, plus 15i square. Plus 15i square. Okay. Now I square is minus 1, that means this is becoming minus 15. So take the real parts together, that means 2 minus 15, because I square is minus 1, plus I times the imaginary part, I times 10 plus 3, that is 13i. So the result will be minus 13 plus 13i. Very simple. That's how we perform the complex number multiplication. Now, same two properties, that is associativity and commutativity. Associativity means, what do I write? Let us write here. Associativity means properties. Associativity. You have three complex numbers, Z1, Z2, Z3, you are multiplying them. Whether you multiply Z1, Z2, Z3 first and then multiply Z1 with the product, the same result will be obtained by whether you are multiplying Z1, Z2 first and then multiplying Z3 with it. Okay, this is the principle of property of associativity. And number 2 is commutativity. Property of commutativity. This is also simple. Whether you are multiplying Z1 into Z2 or Z2 into Z1, doesn't matter. You'll get to the same result. This is how we perform multiplication of complex number. Okay. These are the basic concepts of addition and multiplication. Now we move on to division. If you are done with this, then I'll erase it. Division of two complex numbers. It is also a binary operation. That means you are going to need two complex numbers, A1 plus IB1 and Z2 is A2 plus IB2. Okay. So we need to perform Z1 by Z2. That means A1 plus IB1 by A2 plus IB2. Now the problem is here, you cannot separate the denominator into real part and complex imaginary part. That means you cannot separate A2 just like that or IB2 just like that. Okay. You can separate the numerator, but that won't serve our purpose, because we have to clearly distinguish between the real part of the entire quantity and the imaginary part of the entire quantity. Otherwise, it is not possible to identify the entire complex number. Okay. So basically, what we do here, we multiply by the conjugate of the denominator. What is a conjugate? That means if x is a complex number, z is a complex number x plus iy, then the conjugate of z, that is denoted by z bar, is nothing but x plus iy whole bar, which is nothing but x minus iy. Okay, which is nothing but x minus iy. Basically, if we think of the purpose, the conjugates serve the purpose that if we multiply a complex number to its conjugate, then the product will be a real number. Okay, if we multiply a complex number to its conjugate, then the product will be the real number. Okay, so basically that's why we are going to convert the denominator into a real part. So that's why we are multiplying by the conjugate of the denominator. That means a2 minus ib2. Okay, a2 plus ib2 was the complex number. We are multiplying it by a2 minus ib2. So it's all about the balance. Since I am multiplying the denominator by a2 minus ib2, we have to multiply the numerator also by a2 minus ib2. Let's proceed. So this is the concept of conjugate. We'll discuss about that later. So now multiply. So what is the denominator? Denominator is nothing but a2 square, a plus b into a minus b, a plus b into a minus b, a square minus b square. So a2 square minus ib2 whole square. That is the denominator. Okay. And what is the numerator? Just multiplication of two complex numbers. So a1 a2 minus I square b1 b2, that means plus b1 b2. What is I square? I square is minus 1 and the minus I square b1 b2. So minus of minus 1 b1 b2, that means plus b1 b2 plus I times b1 a2 minus a1 b2, b1 a2 minus a1 b2. So the denominator is nothing but a2 square plus b2 square, because a2 square minus I square b2 square. So minus I square means plus 1. So a2 square plus b2 square. So the denominator is becomes a2 square plus b2 square and the numerator is a1 a2 plus b1 b2 plus I times b1 a2 minus a1 b2. Now easily you can separate the real part and the imaginary part. The entire denominator can be with this part, the real part in the numerator. The entire denominator can be with the imaginary part of the numerator. Okay, that means a1 a2 plus b1 b2 by a1 square plus a2 square plus b2 square plus I times b1 a2 minus a1 b2 divided by a2 square plus b2 square. This is how we perform the division of complex number. This is how we perform the division of complex number. Now, if this part is clear, just take some time and understand the part. If this part is clear, then we move on to example. Suppose z1 is 3 plus 4i and z2 is 5 plus i. We need to find z1 by z2. We need to find z1 by z2. So 3 plus 4i divided by 5 plus I. What is the next procedure? Next process is nothing but multiply the numerator and denominator by the conjugate of the denominator. That is, in case of this, 5 plus I was the denominator. We are multiplying by 5 minus I, that is the conjugate of the denominator. And we are multiplying the same quantity in the numerator also. So the multiplication leads us to 3 into 5, 15 minus 4i square minus 4i square. Minus 4i square means plus 4. Because I square is minus 1, so minus of I square means plus. So 15 plus 4 plus I times nothing but 5 into 4, 20 minus 3. 20 minus 3 whole divided by, this is nothing but 5 into 5, 25 minus I square. So 19 plus 17i divided by, this is the denominator is 25 plus 1, 26. So the answer will be 19 by 26 plus I times 17 by 26. Okay, this is the result. This is the result for division. So why are we multiplying this by the conjugate of the denominator? Just because we can separate the quantities into real part and imaginary part. After all, that is how we can separate a real number from a complex number. If you have a real part and imaginary part in a number, then the number is a complex number, or else if there is no such thing, then that number can be classified as a real number. Okay, so that's why you are multiplying this by the conjugate. Hope you are clear with that. So now practice the sums. Okay, the more you practice, the more this type of problems you will be get acquainted with, and will be in touch with you, and see you in the next video. Thank you.